Hi, scholars. Today we are doing Unit 6, Lesson 10a on understanding each part of a circuit. So today is day one of a two-day lesson. Today and tomorrow we will be building on the content covered yesterday as we started to figure out how to properly connect an electric circuit. Today we will learn about the function of each component within a circuit, and tomorrow we're going to explore specifically focus on the rule of potential difference, which is a concept that is integral to our understanding of the laws that are going to come up later on in this unit. So for today's lesson, we're going to require some sketching of models in order to help you think through some problems. So you're going to need your notebook and, if not, some loose leaf so you can be able to successfully do that. All right. So how we're going to do that is today we have, we're going to start with a do now, then we're going to do a PhET simulation exploration. We are going to examine schematic diagrams of circuits and practice. We'll do a practice, some independent practice, and then just close out with a core idea. So for today, our do now is going to be to, well, in your classwork document, take the next 2 minutes to answer the following question. So below we have two circuits, and you need to explain whether a charge is going to flow or not and why. So take the next 2 minutes to do this. When you are ready to come back, press play. Press pause now. Alrighty, let's check our answers. So for this first circuit, you should have said that no charge is going to flow. And the reason why is that even though my circuit looks like it's connected properly, the switch here isn't closed. All right, so that means that there won't be any electricity flowing. Over here, the second one, charge is not going to flow either. And that's because this loop here is connected in a weird, the wire is connected in a weird way, only to one side of the battery and not to the light bulb. Right? Today's lesson, we're going to continue exploring this deeply, this concept more deeply. All right, so we're going to do a PhET exploration. Take notes of what I'm going to be doing on the exploration in your notebooks. And so let's come up to this simulation. So here I see I already chose some circuit components. I grabbed a wire, I grabbed a battery, I grabbed a switch, a light bulb, and then another wire here. I'm going to be using more pieces of wire as we connect together. So I'm going to start off by connecting my battery to one of the wires. And then I'm going to connect my light bulb to another side of my wire. And now I'm going to put another wire here, and I'm going to connect this side of my wire to the bottom part of my light bulb. So what do you think is going to, right now I have it, I haven't fully closed the circuit yet, I still am holding the mouse. So what do you think is going to happen? As soon as I let go, is the light bulb going to turn on? Let's see what happens. This weird thing is happening where the battery actually lights on fire and the light bulb isn't turned on. We're going to discuss what this means later on, but just note here that actually my wire is connected to both sides. Both sides are connected to the bottom part of my light bulb, so there's actually not like a loop happening here. So take note of this because this is going to come up again later on in this unit. I'm going to break this up to stop that from happening. I'm going to cut that wire too. So now I am going to put this wire on the other side of the light bulb. So see that there's actually two terminals here in my bulb. And I'm going to connect this in. What do you think is going to happen now when I connect these two? Okay, so you probably guessed correctly that the light bulb is going to turn on. Awesome. Right, so here we see These negative circles are charges, so they represent electrons. Right? So electrons are moving through. All right, now let's add, I'm gonna double click here to cut my circuit open. I'm gonna add another wire. And now I am going to connect my switch. So what do you think is gonna happen once I have my switch here? You guessed correctly, nothing is happening. And the reason why is because you see here that the switch is still open. But now what's gonna happen when I'll click on this and I close? You're right, light bulb is gonna light up because now the electricity is able to flow through my circuit. And so let's take a look at what the different components of the circuit are and what's actually happening. So we have the wires here that are, they're the pathway that allows for electrons to flow. Right? So if the wires weren't there, then it wouldn't be possible for the electrons to go through our circuit. The battery here is providing energy for the electrons or the charges to move around in the circuit. So the electrons get energy from the battery, and then they go through our light bulb, and then our light bulb uses that energy to, well, it transforms that energy into light, and then it continues traveling, and then the switch is the on and off button, basically, that allows or prevents the electricity to flow. So I'm gonna add, and here we see the switch is closed, so the electricity is flowing. I'm gonna add one more thing to this circuit. So this little guy here is called a resistor. So let's see what the purpose of this resistor is in our circuit. Actually, okay, so take a note of how bright the light bulb is now and how fast the charges are moving. So you see, so take a note of your observations, and I'm gonna remove this resistor, and then we're gonna see what happens again. So without my resistor, what do we notice about the charges in the light bulb? You're correct in that the light bulb now is much brighter, and the charges are flowing at a faster rate. So I'm going to add my resistor in here one more time, and we're going to play around with it. Right, so again, now we see that the light is dimmer, and then the charges are moving at a slower rate. So if I make my resistor bigger, the bigger I make it, the dimmer my light bulb becomes and the slower the charges move. And then the smaller I make it, then the brighter it becomes, the light becomes, and the faster the charges move. So this is telling me that somehow the resistor prevents electricity from flowing too fast. And it depends on how much resistance, which we're going to talk about later on as well, like how much of a resistor there is there. Alrighty, so now let's move on to formally defining what each part of these circuits do. So take out, in your notebook, you are going to be writing the following definitions. Right, so what is the role of the function of each one of these parts of a simple circuit? Okay, so take the next 30 seconds to write down all 5 of these words, and then we'll move on to actually getting what their function is. Okay, so let's check it out. So, like we mentioned before, and what we observed is that the battery is what gives energy for the charges to flow. Remember to write down these into your notebook. The wire is a conductor that gives a conduit, or like a pathway. Conduit is another word for pathway, for the charges to flow. So we talked about yesterday, was it yesterday? No, we talked about it a few lessons ago, about what a conductor versus an insulator is. So a conductor is a material that allows for charges to flow. So all wires are made out of conductors, and that way electricity will be able to flow easily within a circuit. A switch turns on and off the flow of charges in a circuit. Right, and we see that we see many examples of that in the day-to-day life. Every single electronic that we use has a switch. Right, there's nothing that's constantly going. Right, your phone has an on and off button on the side. If you your TV has the plug. So the plug essentially, when you pull it out of the socket, it essentially works as a switch. What else? The remote control, the power button on the top. The light switch to turn on and off the lights. If you ever get to see the inside of one of those, you'll see that basically all it is just a switch inside. So it opens and closes the circuit, which allows the light bulbs in your rooms to turn on. And then a light bulb uses energy to provide light. So that's the simplest. And then a resistor reduces the amount of current flowing within a circuit. Why would we want to do that? That's something that we're going to get into later on in this unit. It's like, what's the purpose of reducing the flow of electricity within a circuit? It actually turns out that resistors are really, really helpful components of electronics, and we'll explore that later on. All right, so make sure all of these are in your notes, and it's moving along. So a key point for today, also write these into your note, is that if a circuit is broken, either because the components come apart or a switch is flipped off, the current will no longer flow, which means that energy is no longer brought to the loads, such as the light bulb. This word load is the thing that you're trying to power, basically. So in the circuits that we saw, our loads would be considered the light bulbs. Okay? Take the next 30 seconds to write this into your notebook. Press pause if you need. Alrighty. Okay, so now let's move on to modeling circuits. Now that we know what each part of a simple circuit does, it's important to learn the symbols in which electricians and also electrical engineers use in order to draw out circuits. So if we wanted to draw out the circuit that we saw in the simulation with the light bulb and the wire and the batteries, it would be really complicated that every time we try to draw it, we would actually draw a light bulb or we'd draw a whole battery. So scientists and engineers came up with this convention to easily draw the different parts of the circuit. So it's important that you draw all of these into your notes because we're going to be using them a lot from now until the end of this unit. And so you're going to become familiar with these different symbols. If you need to pause the video, do that now and make sure you have them all in your notebook. Okay, so let's put these to practice. So this is an example of what drawing a circuit using schematic diagram would look like. So here we have a drawing of a circuit with 3 batteries and 3 light bulbs, and they're all being connected through wires. Okay, so if we're going to draw the same thing with the schematic symbols, then we would do that by using the battery symbol that we had from the previous slide. So here, this is our battery. So we see there's, in the previous slide, we saw that a single cell here is just one long line and one short line. So this here means my battery, or one cell of a battery. So here, since we have 3, then we're gonna have 3 single cells here, okay? And now we have this connected by a wire to my light bulb. In this case, a light bulb is represented by a resistor. Oftentimes in diagrams, you'll see that a light bulb, you can write this in your notes as a reminder, a light bulb is considered a resistor. And then we'll talk about why that's the case also later on in this unit. But so for this drawing, we have a resistor here, and then again, it's connected to the other light bulb by a wire. and then our second light bulb or a second resistor, and then another wire that's connecting here to our another light bulb, and then our final wire that's connecting to the battery. Okay, and so that's how you would draw these out. And so now you're going to get to practice this on your own. Make sure to have both of these diagrams in your notes, so if you need to pause this to copy it down, please do that now. All right, so now we're trying this on your own. We have a circuit diagram here, a circuit drawing. So now you should try to copy a schematic drawing using the symbols that we just learned. All right, take the next minute or two to do that. And press pause on the video to give yourself enough time. Okay. So moving along, let's see what your drawing should look like. So here I have two batteries. So we know we should have two of these cells here. And then we have two light bulbs, so we have our two resistors. And they're all connected by a loop of wire. So here in this diagram, we have our battery connected to our bulbs through just one loop of wire, right? And then it's closed back to the other side of the battery. Okay, if your drawing looked different than this, please make sure to draw this into your notes so that you have the correct drawing. Okay, so a core idea of today's lesson is that schematic drawings are helpful models that allow engineers and scientists to communicate information about a circuit. So the circuits that we've seen today were very simple, but circuits can get really complicated. And within the remaining of this unit, like I mentioned before, we're going to keep using these symbols with relatively simple circuits. But the more complicated electronics get, the more complicated the circuit diagrams are. So it's really important that scientists are able to use these conventions that are actually universal or global. We use them all over the world. So an engineer from any part of the world would look at this diagram in front of us and would know, okay, so this is a battery with two resistors that are connected. This is important because it's like a universal language, just like math. And if you know any electricians or electrical engineers, you can ask them about how useful this stuff is, especially nowadays when electronics are such a predominant part of our lives. So like, for example, this here is a circuit diagram. I'm not sure what it's a circuit of, like what this thing is, but you can see how they can get pretty complicated, right? And if we had to draw out what each one of these things actually looked like in real life, then it would be too much. So scientists have came up with this convention to make things a lot easier. Those of you who have ever played with the insides of computers, I know some people are into building their own computers. You could have seen like the motherboards or stuff of certain objects kind of look like this, right? The insides of a phone, if you've ever taken apart a phone or an old electronic, the inside of your remote control, they kind of look, the circuit boards kind of look like these diagrams, so they're meant to mimic them. I know this looks super complicated. We're not going to learn about all the details here, but I just wanted to give you guys an idea of how complicated a circuit can get and why it would be useful to have this. All right, so wrapping up, we just complete your classwork for today and make sure you upload the pictures of your drawings to Google Classroom. All right, I hope you have a wonderful day.